Okay, let's check out this numerical. Moment of inertia of uniform circular disk of radius r, capital R, radius r, uniform circular disk, okay, of radius r, and mass m, mass of the disk is m, about an axis and passing from the edge of disk and normal to the disk. So basically what do we have to find? Now this is the disk, alright, this is IC, moment of inertia here, alright, it is rotating like this, moment of inertia here, that is what is, if it would have been IC, then it would have been just this would be the moment of inertia, but what we want is here, alright. So if I take this, it is rotating like this, right? So it is going out like that. So it is rotating like this. So I want to find moment of inertia here, alright, normal, perpendicular to the disk. So normal, I can find it like this also, when we would call it as tangential. If I rotate it like this would be tangential, alright. But if I do it like this would be normal. So what they want is from the edge of the disk and normal to the disk alright. So moment of inertia like this, so it is rotating like this, alright. I cannot show it like that, it is rotating like this. So this is what we want to find out. So this disk is rotating around this moment of inertia, so that is what is I0. And remember, we had studied parallel axis formula, which was equal to I0, that's actual place from where it is rotating. It's rotating like this, right? So I0 is equal to IC plus mh square, where this distance was h, so this distance is h, and coincidentally this is also a radius of the disk. Okay, all right. So what? So formula I0 is equal to IC plus mh square. So let's find out I0. I0 is equal to IC. I told you disk. I asked you to by heart those formulae. Alright, for disk, it is, if it would have been a ring, IC would have been mr square. But now since it is a disk, so it would be half, I would write there, it would be half mr square, since it is a disk, and it would have been mr square if it would have been a ring. You know, just a funny way of keeping it in mind, I just say it like that. Now see, it is filled, still its moment of inertia IC is low, half. Well, this is, I mean, it's just a ring. In spite of that, its IC is pretty high. It's double that. Alright, just a way to keep in mind. If it helps, it's fine. Otherwise, by heart as your way. By heart is as you feel. Okay, so it is IC is equal to half mr square. So we know the value of IC, so why not jot it down? Half mr square. Alright. Plus, I also told h is equal to r. So instead of h, it would be mr square. So LCM thing, I hope now you have learned LCM. So I put a 2. So 2 ones are 2. So it becomes, okay, let me do it again. So 2, it is mr square by 2. So 2 ones are 2. So this would be mr square. And this also I divided by 1. 1 2s are 2. 2 into mr square is equal to plus 2 mr square. So your answer here, this I0 is equal to 3 mr square, 3 by 2 mr square. So the value over here, this is 3 by 2 mr square, and IC we knew was half mr square. Alright, so that's so simple. So this is what is our answer. Okay, 3 by 2 mr square.